At 72 degrees north latitude, 38 degrees east longitude, on February 12, 2025, inside a U.S. government sensor station monitoring the upper atmosphere for ballistic activity, a routine shift was underway. A duty analyst sat with coffee at his side, two screens flickering before him, running the kind of telemetry review that typically produces nothing. Flag log forward, flag log forward. Hundreds of shifts like this had blurred into monotony, and then the sensors tripped. An object entered the atmosphere traveling at 72.4 kilometers per second. He double-checked calibration. He triple-checked. The number didn't budge. His eyes flicked to the velocity threshold table pinned above his workstation. Solar system escape velocity at Earth's orbital distance from the Sun is 42.1 kilometers per second. This object was moving 30 kilometers per second faster than anything gravitationally bound to our Sun could possibly achieve at that distance. He flagged it, logged it, picked up the phone. Within 6 hours, the event was entered into the NASA Fireball database as a routine atmospheric impact. No press release, no announcement. The Barren Sea entry was catalogued, time-stamped, and filed. The world didn't notice. 14 months later, researchers at Harvard running 1 million Monte Carlo simulations on that single entry found something extraordinary. They incorporated measurement uncertainties, atmospheric drag coefficients, Earth's rotational perturbations, and gravitational influences from every major body in the solar system. In every single simulation, all 1 million trajectories, the object's heliocentric specific energy was positive, unbound, definitively interstellar. The analyst's coffee was long forgotten, but the object he logged that afternoon arrived exactly 139 days before 3I. Atlas was detected entering our solar system. This is not a story about a meteor. This is a forensic investigation into 4 separate interstellar objects that impacted Earth across 12 years. Their timing, composition, and the theoretical framework that transforms coincidence into statistical inevitability reveal a pattern the data refuses to ignore. To grasp the significance of the Barren Sea entry, you need to understand escape velocity and what it means for an object to exceed it. Every star generates a gravitational well, a region of spacetime curved by its mass, where objects traveling below a threshold velocity remain bound. For our Sun, that threshold at Earth's orbit is 42.1 kilometers per second. Anything faster carries positive heliocentric specific energy. It is not orbiting, it is passing through. It originated somewhere else entirely. The first object confirmed to surpass this threshold was designated IM-1. It impacted near Papua New Guinea on January 8, 2014, at 60 kilometers per second, the highest recorded impact velocity in meteor observation history. U.S. Space Command data, declassified in 2022, confirmed its interstellar origin. A subsequent ocean floor expedition in 2023 recovered 850 metallic spherules, sub-millimeter droplets formed as the meteor vaporized and condensed upon atmospheric entry. Elemental analysis of those spherules revealed ratios of beryllium, lanthanum, and uranium inconsistent with natural nucleosynthesis in any known solar system environment. Isotopic signatures reflected billions of years of cosmic ray bombardment in interstellar space, material with no known source, entirely foreign. Then came IM-2 on March 9, 2017, impacting the North Atlantic Ocean at 59.8 kilometers per second. Its energy release equaled 3 kilotons of TNT at 31 kilometers altitude. Interstellar origin confirmed. 6 months later, in October 2017, the Pan-STARRS telescope in Hawaii detected Oumuamua, the first confirmed large interstellar object on a hyperbolic trajectory through our solar system. Timing noted. Dismissed as coincidence. Fast forward to the 2 most recent events. CEO's 222, analyzed through calibrated uncertainty models, impacted the eastern tropical Pacific on July 28, 2022, exceeding solar escape velocity by 8.7 standard deviations. Cenos 25 struck the Barren Sea on February 12, 2025, exceeding escape velocity by 5.5 standard deviations. 1 million Monte Carlo simulations confirmed every trajectory unbound. And Cenos 25 arrived 139 days before 3I. Atlas was detected the same pattern established in 2017 when IM2 preceded Oumuamua by 6 months. Theoretical models using Bayesian probability frameworks on this 4-event dataset calculate the likelihood of the 2017 and 2025 temporal correlations occurring independently by chance at roughly 6%. In other words, there's a 94% probability the correlation is real. In any other field of science, a 94% probability drives hypothesis formation, experimental design, and institutional funding. In this case, it drove 2 rejection letters. The Kaku lends the theoretical framework based on string theory, 1-1, dimensional hyperspace architecture, and the Kardashev scale of civilizational energy offers a model for what a technologically advanced system deploying reconnaissance assets across interstellar distances would look like from the receiving end. It would not appear as a clearly labeled spacecraft. It would look exactly like this: small, fast, arriving ahead of the main object, impacting the atmosphere, either ablating completely or deploying a compact payload designed to survive entry. The data suggests a civilization operating at Type 2 or Type 3 energy scale would logically deploy advanced instruments ahead of a primary vessel. Scout probes, atmospheric samplers, sensor packages, targeting the densest information source in the inner solar system Earth. The recovery site for CNOS 25 is not inaccessible. The Barren Sea impact coordinates correspond to a water depth of 230 meters, shallow sediment. The same magnetic sled recovery technique that retrieved IM-1 spherules near Papua New Guinea in 2023 could recover CNOS 25 material. A formal expedition proposal submitted to the National Science Foundation was peer-reviewed by 3 independent scientists, all scoring it excellent. Yet, the proposal was rejected. Reason? Insufficient evidence that recovered material would provide scientifically significant information beyond existing meteorite collections. But an object from another star system, confirmed interstellar, arriving 5 months before 3I, Atlas, at a precise, accessible location in the ocean, and the NSF determined it lacked scientific significance. The pattern is emerging. It's not subtle. 4 interstellar objects in 12 years, 2 arriving in years coinciding with large interstellar transits of the inner solar system. A calculated population density, based on the impact rate, suggests 8.4 million objects per cubic astronomical unit, 35 million interstellar objects inside Earth's orbit alone. The total implied mass is 1,000 times beyond what galactic stellar ejection models predict. The telemetry is not an anomaly, it is a pattern. And in Part 2, we go deeper into the mathematical demands of that population density, why journals rejected the findings not for methodology but interpretation, and what the 139-day intervals really mean. The number alone is staggering: 8.4 million interstellar objects per cubic astronomical unit. Let that sink in. Not 8, not 800, but millions of objects, each roughly 1 to 1.5 meters across, occupying every cube of space, the size of the distance from the Sun to Earth. Inside Earth's orbit alone, the observed impact rate implies a population of 35 million objects at a solid density of 3 grams per cubic centimeter. Each carries around 3 million kilograms of mass. The total implied mass inside Earth's orbit reaches 100 trillion metric tons. To put that in perspective, the entire asteroid belt between Mars and Jupiter, the accumulated debris of 4.5 billion years of solar system evolution, weighs roughly 3 times 10 to the 21st kilograms. The interstellar population implied by just 2 confirmed impacts over 7 years equals 3% of that entire asteroid belt, packed invisibly inside Earth's orbit, unnoticed until collision. This is where physics collides with impossibility, and institutions begin to fall silent. The Milky Way contains between 100 billion and 400 billion stars. Each star ejects material through stellar winds, supernova events, planetary formation debris, and gravitational scattering. Yet the total mass available for interstellar ejection across the entire galaxy produces a predicted interstellar object density, orders of magnitude below what the observed impact rate demands. The density required to produce 2 impacts on Earth within 7 years exceeds what the galaxy's entire stellar population could generate. Only 2 exits exist from this mathematical corner. Either our galactic models are off by a factor of 1,000, requiring a fundamental revision of stellar mass loss rates, supernova ejective velocities, and galactic dynamics, restructuring the foundations of modern astrophysics, or the objects are not randomly distributed. They are not debris drifting passively through interstellar space. They are not fragments scattered over billions of years by dying stars. Something else entirely is at play. Theoretical frameworks applying directed panspermia models, von Neumann probe distribution architectures, and Kardashev-scale deployment logistics converge on one implication: a civilization capable of populating interstellar space with functional objects at this density would not launch each individually from a home system. They would seed prepositioned assets across gravitational waypoints, using the geometry of stellar systems to redirect objects toward high-value targets. The density observed does not reflect total production capacity, it reflects local concentration near a flagged target. And Earth has been flagged at least 4 times in 12 years. The compositional data from IM-1 spherules deepens this framework beyond purely dynamic models. Beryllium, lanthanum, and uranium enrichment in ratios inconsistent with any known natural nucleosynthesis pathway cannot be ignored. These are not merely heavy elements. They require neutron flux conditions found in neutron star mergers, select supernovae, or theoretically, artificial nuclear processes beyond natural stellar physics. The isotopic signatures, accumulated over billions of years of cosmic ray exposure, confirm extraordinary interstellar travel. Yet the elemental ratios at formation do not match any natural source in our catalogs. CNOS 22 and CNOS 25, recorded in 2022 and 2025, reinforce the pattern. A paper documenting these events was submitted to the Astrophysical Journal Letters on February 28, 2026. 2 referees reviewed it. One found it acceptable with minor revisions, the other rejected it not on methodology, not on statistical analysis, not on Monte Carlo simulations, but on interpretation. The objection? That the implied population density could merely reflect improved detection capabilities rather than a physically anomalous concentration. The rebuttal was precise. Improved instruments reveal what was always there. They do not generate anomalies, they expose them. If detection shows a 1,000-fold increase in interstellar material, the anomaly exists in the material, not the instruments. Yet the editor sided with the referee, and the paper was rejected on March 19, 2026. Still, the data was public, the calculations reproducible, the preprint indexed and downloadable by any astronomer. Now consider the temporal geometry the journal refused to acknowledge. 3I. Atlas was detected on July 1, 2025, at a heliocentric distance of 4.1 AU, already deep inside the solar system. Detection is not arrival. Reconstructing the trajectory backward using measured velocity, 61 km per second, and orbital elements places 3I, Atlas crossing Neptune's orbit at 30 AU in late 2024, Uranus at 19 AU in early 2025, Saturn at 9.5 AU, and Jupiter in March 2025, 1 month after CNOS 25 impacted the Barren Sea. If CNOS 25 separated from 3I, Atlas, while the main object was still beyond Saturn, 4 to 5 AU from Earth, and received a small velocity adjustment targeting Earth, the alignment is exact. The probe separates at distance, accelerates along a targeting vector, and impacts Earth's atmosphere at 72.4 km per second. It either ablates completely, destroying physical evidence, or deploys a smaller payload, a sensor package, a transmitter, or an instrument designed to survive entry. It lands on the Barren Sea floor at 72 degrees north, 38 degrees east, in 230 meters of soft sediment, sitting recoverable for 13 months. The same magnetic sled technique that retrieved IM-1 spherules could locate CNOS 25 material to within 5 kilometers. A proposal with 3 excellent peer review scores was rejected by the NSF, citing insufficient scientific significance. But there is no collection on Earth containing IM-1, class isotopic anomalies. No repository contains material confirmed interstellar, arriving 5 months before a precision-targeted object like 3I, Atlas. Every recovery site, every proposal, every attempt to document these objects meets institutional resistance, precisely to prevent evidence collection. And the most significant question emerges: if CNOS 25 was a probe, deploying a payload that survived atmospheric entry, then 3I, Atlas, did not reach Jupiter's Hill radius unaware. The main object received data in advance. Any decisions, orbital insertion, energy harvesting, transmissions were informed by 13 months of Earth observation. We were not merely observers. We were the destination. In Part 3, we will synthesize this fully. We will connect IM-1 spherules to string theory frameworks for artificial nucleosynthesis, analyze what a von Neumann probe architecture looks like at interstellar deployment scale, and address the question that has haunted this investigation since 2014. If they have been observing since IM-1 and CNOS-25 was the final reconnaissance, then the calculated orbital convergence at Jupiter's Hill radius is not a destination, it is a response. The story is only deepening. The pattern is undeniable, and what was once dismissed as coincidence now demands we confront the possibility that Earth has been actively observed, studied, and marked by objects far beyond our technological comprehension. Part 3 begins where Part 2 left off, at the heart of the pattern that refuses to be ignored. The data, the impacts, the elemental anomalies, they all converge to tell a story that is impossible to dismiss. IM-1, IM-2, CNOS-25, and 3I, Atlas are not isolated events. They are chapters in a deliberate, sequential reconnaissance, a methodical observation of our planet by something far beyond our comprehension. The IM-1 spherules recovered in 2014 contained elemental ratios inconsistent with any natural nucleosynthesis pathway. In the framework of string theory's 1-1, dimensional hyperspace, these ratios are not just unusual, they are precisely what would be expected from artificial nucleosynthesis at a Type 2 civilization scale. The universe as we know it does not naturally produce these ratios. They require manipulation of energy at levels impossible in four-dimensional spacetime but feasible in the context of higher-dimensional physics. Each droplet, each beryllium, lanthanum, and uranium ratio tells a story of technology far beyond our own. Now, apply that same logic to CNOS-25 and its timing. 5 months before 3I, Atlas, CNOS-25 arrives, precisely targeted, impacting the Barren Sea at 72.4 kilometers per second. It either ablates entirely or delivers a payload to the ocean floor, recording or transmitting data about Earth's atmosphere, surface, or magnetic fields. This data then informs 3I, Atlas, allowing the main object to execute precision trajectory corrections on approach. The mathematics, the orbital mechanics, the Monte Carlo simulations all align perfectly. Earth was not merely in the path of an interstellar visitor, Earth was the target of careful observation. The von Neumann probe framework, which models self-replicating, interstellar reconnaissance probes, offers insight here. A civilization capable of Type 2 or 3 energy output could deploy small, highly resilient probes ahead of primary objects. These probes would gather critical data, including planetary composition, orbital parameters, magnetic field strengths, atmospheric properties, and perhaps even signs of technological activity. CNOS-25 fits this model exactly. It arrives ahead of the main object, delivers a payload, and positions the primary vessel 3I, Atlas, with complete awareness of the planetary environment. The implications are staggering. Every institutional obstacle, the rejected NSF proposal, the journal refusal, the denial of recovery expeditions now forms a pattern of suppression rather than coincidence. The evidence sits, accessible, recoverable, and ignored. Every step of the process, from Monte Carlo simulations to elemental analysis, points to an intentional sequence. Reconnaissance first, then approach, all perfectly aligned with interstellar dynamics and human observation windows. Consider the elemental data again. These are elements whose production requires extreme neutron flux, conditions normally found in neutron star mergers, select supernovae, or artificial processes beyond natural physics. The isotopic signatures, showing billions of years of cosmic ray exposure, confirm these objects traveled interstellar distances, yet their formation ratios cannot be traced to any natural source in our catalogs. The combination of timing, trajectory, and composition cannot be random. IM-1 in 2014, IM-2 in 2017, CNOS-25 in 2025. They are sequential reconnaissance events. Each prepares the next object for targeted arrival. By the time 3I, Atlas, reaches Jupiter's Hill radius, it is already acting on information collected months earlier. The main vessel's decisions, orbital insertion, energy harvesting, or transmission, are informed by data from the probe it deployed ahead of itself. Humanity has never been the passive observer in this sequence. We were, and are, the destination. The Barren seafloor holds the answer, quietly, at 230 meters depth, 13 months of observation recorded, untouched. The theoretical synthesis is clear. 4 interstellar objects, 12 years, 2 perfectly aligned with major interstellar transits. A population density 1,000 times higher than what galactic models predict. Material with isotopic and elemental compositions inconsistent with natural processes. Rejected funding proposals, suppressed recovery efforts, institutional silence. Every data point converges on a single conclusion. A civilization with interstellar reach has methodically studied Earth using reconnaissance probes ahead of its main vessels. This is not science fiction. The telemetry, the spherules, the trajectories, the orbital reconstructions, the Monte Carlo simulations, all reproducible, all public. The evidence does not scatter, it converges. The sequence is deliberate, the scale vast, the precision impossible to attribute to chance. IM-1 first made contact in 2014. IM-2 aligned with Oumuamua in 2017. Xenos 2.5 arrived 5 months before 3I, Atlas in 2025. Each impact an event, each preceding a larger object, each leaving traces that remain recoverable but deliberately ignored by institutions capable of acting. The music of the spheres does not require permission. The trajectory data is published, the spheral analyses are indexed, the simulations can be run by anyone with the software and datasets. They sent probes ahead, the probes reported back. And 3I, Atlas is now executing maneuvers fully informed by what was discovered on Earth months earlier. We have never been the observers. We have always been the observed. And now the question that defines the next phase of this investigation. If Earth has been the target of sequential interstellar reconnaissance, what does that mean for humanity's understanding of our place in the cosmos? How many other worlds are catalogued, measured, and studied by technologies far beyond our comprehension? How do we respond to a pattern that has been visible for 12 years, entirely reproducible, entirely public, yet systematically ignored? The story does not end with denial. It continues in the data, in the trajectories, in the elemental fingerprints of objects that have already passed through our solar system. And for those willing to explore, analyze, and investigate, the opportunities are unprecedented. The ocean floor holds the answers. The trajectories are calculable. The anomalies are reproducible. Now, it's your turn to witness the evidence, share the discoveries, and push the boundaries of what we know. Download the public datasets, run the Monte Carlo simulations yourself, examine the elemental ratios, and trace the orbital mechanics. The sequence is clear, the data is there, the interstellar reconnaissance has already occurred, and humanity has the chance to engage directly with one of the most extraordinary scientific mysteries ever recorded. Don't let this story end as suppressed reports and rejected proposals. Explore, analyze, share. Humanity was never merely watching the stars, it has been the destination all along.